Hello everyone, today we're doing the second method of factorizing quadratic expressions. The first method was completing the square, which I covered in the previous video. In this video we'll be covering middle term breaking. Now to start off with middle term breaking, we need to revise what factorization actually means. It means breaking a number into its factors, and factors are numbers that multiply to give us a bigger number. So what I mean by that is 6 can be factorized into 2 times 3. 8 can be factorized into 2 times 2 times 2. 9 can be factorized into 3 squared. X squared can be factorized into x times x. Now what a quadratic essentially is a product of two linear factors. For example, x minus 3 and 3x plus 2. If I multiply this, if I expand this expression, I should get a quadratic. So let's do that right now. I'll expand this by multiplying x with this bracket and minus 3 with this bracket. So x into 3x plus 2 minus 3 into 3x plus 2. So this opens up into 3x squared plus 2x, and the second bracket opens up into minus 9x minus 6. And I can further simplify this into 3x squared minus 7x minus 6. And so I've gotten this quadratic in the general form that quadratics are expressed in, which is ax squared plus bx plus c, where 3 is a, b is minus 7, and c is minus 6. Now how do we break the middle term, which refers to minus 7 in this case, and in general the middle term is the x term. We break it into two numbers so that it gives us, the two numbers give us the product of a and c, and they add or subtract to give us b. So what I mean by that is, taking this example, 3x squared minus 7x minus 6. Let's do this in steps. So the first step would be to multiply a into c, in which case, in our case, it is 3 into 6, which gives us 18. The second step would be to write down the factors of 18. So that the numbers, or actually let's just make it step 3. So the factors of 18 can be written in as 3 times 6, or 18 can be written as 2 times 9. Now these are combinations that give us the same product as 3 times 6. So the first condition of having two numbers so that they multiply to give us a and c is complete. The second condition is that they should add and subtract to give us the b term, which is minus 7. Now 3 and 6 do not add or subtract in any way to give us 7. 6 plus 3 is 9. 6 minus 3 is 3. Minus 3 plus 6 is also 3. 3 minus 6 is minus 3. In no possible permutation can 3 and 6 give us minus 7. But 2 and 9 can give us 7. 9 minus 2 is positive 7. So minus 9 plus 2 should give us minus 7, which is our middle term over here. So it's safe to say that I can break down my middle term. Break the term when the two conditions have been met. And I'll write down the two conditions, which are the numbers the two numbers should multiply to give a times c, and they should add slash subtract to give us b. Now with this 3 and 6, they do multiply to give us a times c. Now a times c is 18 because our a is 3 and our c is 6. So 3 times 6 is 18. So 3 and 6 do give us 18, but 3 and 6 do not add or subtract to give us minus 7. So this, even though it fulfills the first condition, it does not fulfill the second condition. So let's just cross this one out. The second pair of factors, 2 and 9, they do multiply to give us a times c, which is 18. And they also add or subtract to give us the middle term, which is minus 7. So 3x squared minus 7x minus 6. Now to break them down, I can write it as 3x squared minus 9x plus 2x minus 6. Note that if I had these signs any other way, for example, if I had 9x minus 2x, it would give me a positive 7x. In my quadratic, it is a negative 7x. So we need to make sure that the signs always give us our b term exactly. The signs need to be correct. Minus 9x plus 2x will give me a minus 7. And from here on out, it's just factorizing. So we take the common factor from the first two numbers, which is 3x is the common factor, and factorizing out 3x from 3x squared, I'll be left with x. And if I factorize 3x out from 9x, I'll be left with minus 3. And 2x and minus 6, the only thing they have in common is 2. So I'm left with x minus 3. And now that I have this is one term and this is one term, and what's common in these two terms is the bracket x minus 3. So I can take x minus 3 common as the common term, and what I'm left with inside the brackets is 3x plus 2. And once we've gone back from this form, ax squared plus bx plus c, into two linear factors, we have successfully middle term broken it. Now let's do two more examples. The next example is 2x squared minus 7x minus 4. So again, the first step is to multiply a and c. A and c in this case are 2 and 4. So 2 and 4 multiply to give us 8. Let's just write it. 2 times 4 is 8. So the first step is to multiply a and c. The second step is to find factors of 8 that add or subtract to give us minus 7. So 8 can be broken down into 2 times 4. Will 2 or 4 in any scenario add or subtract to give me minus 7? No, they won't. So 8 can also further be broken down into 2 times 2 times 2, which also will never add or subtract to give me minus 7. So what else can we break down 8 into? Into 8 times 1. Can 8 times 1 give me minus 7? Let's see. 8 plus 1 is 9. 8 minus 1 is 7. This is close, but it's not quite the same because this gives us positive 7 and what we need is a minus 7. So what if we flip the signs? 1 minus 8. This gives us minus 7 and this is exactly what we're looking for in the middle term. So once we're satisfied with this, let's just break it down. So 2x squared minus 7x minus 4 equals 2x squared minus 8x plus x minus 4, or you can write it the other way around as plus x minus 8x minus 4. And now you just factor out the common terms. So the only thing common between 2x squared and x is x. So if I factor out x, I'm left with 2x plus 1. And the only thing common between these two is minus 4. Note that we're always supposed to go for the highest common factor. In these two, we also have minus 2 common, and we have minus 2 common as well. But we're supposed to take the highest integer value, which is 4. So minus factoring out minus 4 will give me 2x plus 1 inside the bracket. Now note that I could have also factored out a positive 4 from here, in which case I would have been left with a minus 2x and minus 1 inside the bracket. And while these two brackets are similar, the signs are different, so I won't be able to factorize this bracket out. So I need to make sure that the bracket I get is such that I'm able to factorize it out again. So we take minus 4 as the common term and we're left with 2x plus 1 inside the bracket, and now we can factor out this bracket as whole. So 2x plus 1 and we're left with x minus 4, and we successfully middle term broken it, or we've broken the middle term successfully. And we'll follow the same pattern with this quadratic. A times c equals 6 times 4, which is 24. Now we need factors of 24 that add or subtract to give me minus 10. So 24 equals, let's see, 3 times 8, and 24 equals 2 times 12. 24 equals, let's say, 4 times 6. Now in this case there are two pairs of numbers that satisfy our middle term. It can be either 4 or 6, because 4 and 6 add up to give us minus 10, and 2 or 12 also add or subtract to give us minus 10, because 2 minus 12 equals 10 minus 10, and minus 4 minus 6 also equals minus 10. So in this case, which one do we choose? We choose the one that also satisfies our needs for this sign. So 6 into 4, a into c, gives us a positive 24, right? So what we need from these two numbers is that the final numbers that we choose, including the signs, should multiply to give us a positive 24. Now let's suppose I take this option. 2 and 12. The way 2 and 12 give me a minus 10 would be if I take positive 2 and minus 12. This gives me a negative 10. But if I multiply these two numbers, 2 into minus 12, they give me a minus 24. This conflicts with our actual product of a into c, which is a positive 24. So what do we do? Let's try this third. third factor. 4 into 6. 4 into 6 is 24, and the way I'll get minus 10 with 4 into 6 is minus 4 minus 6 gives me minus 10, and the product of minus 4 and minus 6 gives me positive 24. This meets my condition of wanting a positive 24. So we go with the third one. So 6x squared minus 4x minus 6x plus 4, and now we just factorize out our common terms. So what 6x and minus 4x have in common? It's 6x squared actually. Have 2x in common. So 2x factorized out, 3x minus 2 stays in the bracket, and what minus 6x and plus 4 have in common is minus 2. So we're left with 3x minus 2. Now note that I could have also taken positive 2 common, but inside the bracket then I would have had minus 3x plus 2, which even though the numbers are same, their signs are different, so I can't factorize them. So it was important to take minus 2 as the common factor, and then I can just factorize out 3x minus 2, and I'll be left with 2x minus 2.